Today we're going to look at the Nelson College maths paper practice exam for investigating relationships between tables, equations and graphs. Okay, it's important to remember that this standard is looking at how you can relate tables, equations and graphs, so we want to be using one or more of these in every question. Some of the questions can be answered by a guess and check, but that's not going to get you very many of the marks. Let's look at question 1. In question 1, Peter has made a pattern with T-shaped designs using squares formed from matchsticks. Here's the first design, a slightly bigger second design and a bigger third design. And we're told the first design has 5 squares and uses 16 matches. How many squares will there be in the 6th design in this pattern? Now we could try and draw the 6th design out, but remember I want to use tables, equations and graphs. In this case I'm going to use an equation. By examining the first 3 designs for the number of squares, I see that the second design is a copy of the first with 3 squares added on. The third design is a copy of the second, again with 3 squares added on. So I can see that my pattern is going up by 3. This means that the number of squares is 3 times the number of the pattern plus or minus something. Now, we're told the first pattern had 5 squares. So when n is 1, s equals 5. To make my expression 3n plus something equal 5, it must be 3n plus 2. Now I can use my equation that I've formed and substitute in n equals 6. When n equals 6, s is 3 times 6 plus 2, which equals 20. So it has 20 matches. Now if you'd drawn the pattern or somehow worked out that it was 20, just having the answer alone would give you a U-tick. Having the equation and the answer in this case would give you your R-tick for a merit. In the second part, we're asked about how many matchsticks will there be in the 6th design. So again, n equals 6, and I'm going to use an equation to solve this. I can see that each time I go up by 1 in the number in the pattern, I'm adding 1, 2, 3, 4, 5, 6, 7, 8, 9 matches. And again here 1, 2, 3, 4, 5, 6, 7, 8, 9 matches. So I know that the number of matches must be some function 9 times the size of the pattern number plus or minus something. Again, the same as before. How can I work out the plus or minus something? I see that for the first design I'm told there are 16 matches. So when n equals 1, m equals 16. If I substitute n equals 1 in here, I'll get 9. I need a further 7 to get my 16. So the equation must be the number of matches equals 9 times the pattern number plus 7. Now when n equals 6, for the 6th design, n equals 6, m equals 9 times 6 plus 7, which is 54 plus 7, which is 61. Again, you could have drawn the shape and counted the matches, and you would have found that 61 was your answer, so you get a little U-tick. But if you formed your function as well using the equation, you would get a merit tick there. Remember, we want to try and form equations, use tables or graphs. Now in the first 6 designs, how many matches are there altogether? I'm going to use a table this time because I know my equation and I know that I want to add the first 6 together. So I'll have n and m, the number of matches in the nth design, and I just need to substitute in 1, 2, 3, 4, 5 and 6. When n is 1, I'll have the number of matches for the first, which is 16. 9 times 1 plus 7 is 16. When n is 2, I'll have the number of matches for the second design. 9 times 2 is 18, plus 7 is 25. And so on, 34, 43, 52 and 61. And then by adding up for my 6 designs across the table, I'll be able to find how many matches altogether. When I add up these numbers, I get a total of 231. Again, simply giving this number somehow would give you a U-tick, but showing a method, laying it out in a table, would give me my merit tick. So the key to getting some merit marks here is to show equations or use tables. Let's flip over to D. Peter has a box of 200 matches. Find the position in the pattern of the single largest T-shaped design that he could complete using the matches from his box. So we know that the number of matches equals 9 times the number of the design plus 7, and I want the biggest value of n when m equals 200. So I'm going to substitute m equals 200 into this equation and solve it. I'll take 7 from each side, and then I'll divide by 9. N is 21 4/9. Now clearly we can't have part of a pattern, we can only make complete patterns. So the biggest complete pattern that Peter could make would be design number 21. For this, simply working out design 21 would get you your achieve tick. But setting up and solving the equation will take us all the way through to excellence. In fact, setting up the equation alone was enough for a merit tick. Solving it and then putting it into the context would give us our excellence tick. The final part of question 1 talks about Peter having 500 matches altogether. With this box of matches, how many complete T-shaped designs could he make? He plans to start with the first design. So he's going to make design 1 and then design 2 and design 3 and so on until he's used up his 500 matchsticks. If I look back at the working I did for part C, I can see that 231 matchsticks would allow me to do all the first 6 designs. So I'm going to continue my table from 6 designs onwards to work out how many more shapes I could do. So m equals 9n plus 7. That's the number of matchsticks for the design. So I know from 1 through to 6, and we'll keep a total here. The first one was 16 matches, the 6th one was 61 matches, and when I added those up, I had a running total of 231. Now I want to keep going to see how many more I can put in. So if I put in design 7, that'll take me 70 matches. 9 sevens plus another 7 is 70, and my total will be 301. I still haven't used all my 500, so I can keep going. Design 8 will use 77 matches. No, it won't. It will use 79 matches. 9 8s are 72 plus 7 is 79. 79 more matches. I'm up to 380 in my total. I've still got some left. My 9th design will use 9 9s 81 plus 7 is 88. If I add my 88 onto there, I've now used 466 matches. I'm starting to get close to that 500, but I really want to check. Can I do my 10th design? My 10th design will take 97 matches, which takes my total used to 563. So that's too many. Okay, the most he can make is 9 complete T-shapes. So there I've used my equation, I've continued my table from part C, and I've found that this here is the most I can get out of my 500. It's 9 designs. Now for that, simply giving 9 as your answer would give you an achieve tick, and extending your table from before, because we're just building on that previous idea, that would give you your merit tick. So that's question 1 complete. Now how do we pull together the marking for that? Okay, so for determining the mark for this particular question, we've got this grade scheme here. You'd get an N0 if there was no response or no relevant evidence, an N1 for a partial evidence in one question. If you had 1 U tick, so 1 achieve tick like this one here, over the whole question you'd get an N2, 2 achieve ticks, 2 U's in A3, 3 achieve ticks in A4, and so on. In this question here, there was only one opportunity to get a T, and that was in part D, so the highest grade you could get for this would be an E7. I think I've done pretty well here. I'm going to give myself an E7, and then we'll go on and we'll have a look at question 2.